Hi there and welcome. The molecule that I've decided to discuss today in this vlog is that of carbon, and in particular, carbon fiber. I have chosen this molecule due to the fact that it is being increasingly used in the construction of commercial and military aircraft. This has particular importance to me as I am intending to specialize my engineering degree into the field of aeronautical engineering and then pursue a career as a pilot. Carbon fiber is used in aircraft through what is known as a composite material, or in this case, carbon fiber reinforced polymer. These composite materials are now being used for approximately 53% of an airplane's body, and are replacing other materials such as aluminium or steel. The particular properties that carbon fiber reinforced polymer provides is that it is incredibly strong when compared to wood, glass, or steel. However, it is approximately 20% lighter than aluminium, which is the closest competing material on the market. So what is it about the molecular structure that provides them with such strength, yet at the same time lightweight? Let's take a look. Carbon in its simplest form is an element with an atomic mass of 12 and an atomic number of 6. Carbon fiber itself is made up of lots of individual carbon atoms, strung together in a hexagonal shape and connected using covalent bonds. This bonding means that there is no polarization between atoms, which in turn means that all electrons are shared equally between the atoms. The incredible strength of carbon fiber, which was mentioned earlier, comes down to the hexagonal arrangement of the atoms. This hexagonal arrangement means that each carbon atom is bonded with 3 other carbon atoms, with each of these giving off 4 valence electrons. These electrons are then shared evenly between the atoms to create very strong intermolecular forces and provide carbon fiber with incredible tensile strength. This hexagonal sheet of atoms is, however, almost identical to that of graphite, which we know is a much softer and flakier material. So why is carbon fiber so much stronger than graphite? The strength of carbon fiber as a larger material, not just a single sheet of atoms, actually comes down to how the sheets of carbon are arranged. Taking these sheets of paper as sheets of carbon, in graphite, the sheets are placed evenly on top of each other with very weak forces holding them together. This means that when a force is applied, they essentially fall apart. However, in carbon fiber, the sheets are placed together in a much messier format and are actually folded on top of themselves. This causes crystallites to form between the layers and makes it incredibly hard for the layers to be separated. The second property of carbon fiber that makes it so unique and popular is its lightweight. Carbon fiber itself is very lightweight when compared to steel or aluminium, basically because it is made up of purely carbon atoms which have a very low atomic mass. However, we very rarely use carbon fiber in a pure format. Carbon fiber is actually so strong that we don't need to use a lot of it to match the strength of aluminium or steel. So in an effort to save cost and resources, we combine it with another material such as epoxy resin to create a composite material. This composite material is therefore only part carbon, part polymer, thus giving it an even lower density than before. This use of a polymer also adds to the strength of the material, as carbon fiber typically buckles or bends under compression forces, but a solid polymer base will be able to resist these. The only downside to carbon fiber that we currently face is that it is very expensive to produce, and because of this, aviation companies have been hesitant to use it. However, as decades go on, the prices will continue to drop, and I'm sure that I'll be seeing a lot more of carbon fiber not only in the aviation industry, but in all aspects of life.